quick intro of myself. My name is Mark Franco. I'm an Azure architect in the Microsoft Technology Center. And for those of you who don't know what the MTC is, or Microsoft Technology Center, we love our acronyms, right? It's a place where customers can come and talk to real architects in Microsoft. So industry architects that have been in the biz for 10, 15, 20 years. Myself, I worked in Microsoft Consulting Services for over 12 years, developing solutions for clients, SharePoint solutions. That's where all the white hair came from. Things like DevOps. DevOps back then obviously wasn't called DevOps. We'll get into that in a bit. But primarily my main job at the MTC is to help remove blockers for customers. And I encourage all of you to reach out to your Microsoft reps. If it's something that you're interested in, bringing your customers, bringing your team that you work with at work, absolutely. We'd love to have you into the MTC. We do things from high-level 100 conversations such as this, right down to 400-level detailed architecture design, validation, and obviously secure DevOps. So with that, let's just move on here. I wanted to start with this slide just to give you an idea. The next couple slides really are talking about how Microsoft delivers software, right? So when I first started at Microsoft over 13 years ago, delivering software was, hey, here's a nice shiny package at the end. Here's a box. Take this DVD and install it on your machine. And we would see those releases happen maybe once every year, every 2 years, right? We can't do that anymore, right? The pace of innovation, disruptors. If you look at companies that are typically not software companies, like if you look at Uber, what they've done to the taxi cab industry, huge disruptor. Now, for them to be successful at this, they have to release features almost on a daily basis to be able to keep up, right? Now you have all these other competitors in this space now. Lyft is another one, right? It's going to constantly grow, but what I'd like to show you here, and I'm not going to go through each one, I believe the slide decks are going to be shared, so that, yes? Okay, perfect. And I'll let you go through that, and I prepared this slide specifically to show you how we've changed over the last 20 years in delivering software, right? You can see things like, before looking at DevOps, 4 to 6 month milestones, right, to release a feature. A bit crazy, right? Now we're talking about 2-3 week sprints. If you look at our cloud platform, now Microsoft has 3 clouds, we'll get into that a little bit later, but the primary cloud I'm talking about is Azure. Features roll out on a bi-weekly basis. How can we do this in a way that's automated, is quick, and encompasses security at its heart? Okay, we'll go through that in a bit. One other tidbit that I just want to make prevalent around this is we're a security company moving forward. Microsoft spends over $1 billion a year in security tech alone, right? So it's not just about tools, it's not about software, it's about the whole thing. Like they were talking about earlier, great presentation on talking about people, process, and tools, right? You can't make security happen with 1 or 2, you need all 3 facets, okay? We'll talk a little bit more about what we do to protect our customers in our cloud platform as well. Now, as you can tell, I'm going to talk a little bit more practical in some of the tooling, right? I will kind of give you a high level of what we offer in the DevOps space. I'm not going to go too much into the theory around that, but I just want to make you aware. We have 20 minutes for the conversation, and I'd hopefully like to fuel that conversation for you so you can bring that back to your organizations and start looking at the tools that we offer. Okay. I was very excited when Satya was mentioned new CEO. Having a technical person at the helm of Microsoft changed us dramatically. One of the big points around having someone technical is we're looking at how we can leverage technology and taking that technology and making a difference at customers, right? It's not so much about, selling those server licenses and CALs anymore. It's about building out software that people can use and make their everyday lives more efficient and better. Okay? That is Satya's mandate, and as you can see here, judge us by the actions of today, not where we were 10 years ago. It's a very different company. Focus has changed. We're looking at building out software, services, solutions for our customers. So let's take a step back. I don't want to naturally assume everyone knows DevOps here. Now, just a quick show of hands. DevOps engineers? We've got a few. Now, the information security architects willing to raise their hand, let's see. The other ones are denying. Okay, so that's fine. Always the case when you ask that question. That's great. So let's just have a little high level about DevOps. Never mind the secure DevOps aspect of it. Let's talk about DevOps. What does it mean? Right? So one of my jobs when I first started in the industry over 23 years ago was labeled as a position called a SCM engineer. Does anybody know what SCM stands for? Sir? Software Configuration Management. So basically, if you think about it, that was kind of the genesis of what DevOps is today. It's understanding what you have, right? How to build it in a repeatable fashion. Back then, we used CMMI level models to kind of gauge our maturity on how well we can build software. But it was a big change in the industry, right? We were building out these large labs and building software, releasing them out to environments. And back then, I worked in the aerospace industry, and we had these large labs and would deploy these services. When we got to the deploy phase, very different than what it looks like today. Back then was, here's this monolithic DVD with all this binaries sitting on this. Here's a Word document that's 200 pages long. This is how you release your software into your production environment. Nowadays, we have DevOps tooling and release definitions to make that happen in an automated way. Okay? One product that we have at Microsoft is what we call Azure DevOps. Anybody heard of that? A few of you? Okay. Formerly known as VSTS, or Visual Studio Team Services. Now, if you're a little bit older like myself, we had a product called Team Foundation Server, which would be installed locally in your environment, right? That was kind of the genesis of what Azure DevOps is today. Okay? Idea to be able to store source code in a repository, collaborate on it, have work management capabilities using agile templates, CMMI level templates, build services, release services, testing capabilities, and then continually automating that. That's built into one large product. Today we call that Azure DevOps. Unfortunately, we changed the name to Azure DevOps. It's a little bit of a misnomer. It's not just about building Azure-related services. It's actually one of my favorite products in Microsoft because it is, by definition, a DevOps pipeline tool right across the board. What's important about that is it provides tooling right across the board, from build management to release management to test management. And you know what? You can plug in your own open source capabilities along the way. You don't have to use ours. And that's actually our messaging from our standpoint is, you've already invested in something like TeamCity for release management, or something like a Jenkins build server so you can perform compilation, as well as have some SecOps around initiating sonar cubes. Absolutely. Use that in a Jenkins server, but let's call it from Azure DevOps as a single pipeline. What's really cool about that is we provide the glue. Okay? What's important about that is auditability, traceability, understanding from bug inception all the way to release and continual improvement. I can now track the overall life cycle of that particular feature, release, or bug. Right? Very important. So in the open source world today, there's a lot of tools that do a lot of these individual tasks. Problem is gluing that auditing capability together and providing those dashboards and roll-ups in a single pane of glass. Okay, like I said before, DevOps is union of people, process, and tooling. Again, where we're talking earlier, we had a brief discussion before I came on stage. Most important thing, forget about the tooling, right? I mean, for those people that are not familiar with DevOps and how that kind of works, the tooling has finally caught up to automate a lot of the human aspects of automation, things like workflow and integration between pipelines. But most importantly, it's people and process. Understand, nail that down. That is key. We don't care if you're using PowerShell scripts, Bash scripts to execute on what that process is. Most important part is know what you got and know how to build it, right? Then enter the tooling. If you don't got the first 2 steps done properly, the tooling is not going to help you. But now we're at the phase now where the tooling greatly automates a lot of those tasks for you. Okay, you're going to hear these terms as well from a DevOps perspective. You're going to hear continuous integration, continuous deployment, continuous learning and monitoring. All things that are built into Azure DevOps as a product, it's also built into our cloud platform as well. Okay, so things like continuous integration. Anybody know what continuous integration is? We have a few people, okay, probably all the DevOps guys, girls. Basically, the ability to, on a high level, build some software in a fashion that allows us to continually get better at writing code. Now, that's a very simple definition. Now, from a practical standpoint, let's talk about this. My developer writes a line of code, checks it into a branch that's not the master branch. As they're checking that in, we can enable what we call continuous integration. With continuous integration, it will automatically trigger off a build. Build that code, perform the analysis that needs to happen, then trigger off a release into a dev integration environment and run a series of tests. Let's say I'm running 10 tests as a result of this particular software build. 9 out of 10 pass, 1 fail. I can now, through the DevOps pipeline, actually disallow that check-in to happen and report back to the developer, hey, your line of code broke something in the build. Not just from a compilation perspective, but from a complete end-to-end test perspective, right? So you're gonna see, you hear a lot of that in the open source world and single page applications, E2E, end-to-end type of scenarios. This is where continuous integration really starts to come into play. This is actually the starting point when we start talking about security within DevOps. How do I do things like static code analysis? Integrate that into your CI, right? So if I can look for things like credentials that are stored within my ARM template within an Azure file, I can quickly scan for those using CredScan. It's part of a toolkit that we have within Azure DevOps, automatically breaking my build, right? So things of that nature, we really want to automate. We want to get away from the fact of having someone continually scanning these sort of things or having external systems do this. If we can integrate that through the pipeline, it makes for a seamless experience. Okay? Continuous deployment. So we kind of alluded to this a little earlier. We're not in an age anymore where we're building these massive infrastructures that just sit there, right? So we build an infrastructure. We have a long Word document that shows us how to do that. Let's say it's Windows Server or Linux, whatever it might be. And then we continually deploy source code. New revisions get built and released to that environment. Continuous deployment is not just about source code anymore. It's about infrastructure. So you're going to hear that term, IAC, or infrastructure as code. Now I can define my infrastructure in a way that's declarative in this long document. Sorry. This long document that basically describes how my infrastructure is built. Now, there's multiple clouds, AWS, Google, they all do their own sort of thing. In Azure, we have this concept called an ARM template. It's basically just a long JSON string that defines how my PaaS web server is built, or my series of VMs, or my entire VNet architecture, all within a line of code. I can take that, put that in source control, and then I can deploy that through a release pipeline, deploy my infrastructure, deploy my code on top of that, and build my solution from end to end, right? Very powerful capabilities, right? Also test things like, hey, if in case of disaster, I need to rebuild this environment. Hey, everything is within a JSON document, okay? So that's where continuous deployment really starts to come in. Continuous learning and monitoring. This is really built into the platform itself. Depends on the nature of the services that you're building. On-premise services versus cloud services. We have tooling called Application Insights that you can instrument right into your code base. Without writing a line of code, I can now see things like internal server errors. I can see authentication errors, 401 errors for web-based applications, and have those surface up into a central logging repository called Log Analytics, and visualize that through Power BI technology. Now, if you're not familiar with Power BI technology, that's our new kind of, if you will, BI front-end capability that allows you to visualize data objects either in real time or from static-based databases. Okay, so what is Azure DevOps? So Azure boards, so work management. If you're familiar in the open source world, Jira is one of the competitors in this space. Azure pipelines consist of multiple areas. So what's cool about this is, let's say I have a source code repository sitting in GitHub or in a Git server, or maybe even a private Bitbucket, right? I can use Azure pipelines to tie into that. We support any type of source repo, and I can build that code, release it in a secure fashion. I can peer right into that. You don't even have to use our source repository, right? Azure repos, we support Microsoft technology, which is TF-VCS, which is our standard source repository. We also support Git natively. So that means you can have a private Git repository, distributed source repository, native into Azure DevOps, bottomless source code repository. Azure test plans, Azure artifacts. So basically being able to create your test plans and kind of integrate your security ops in there as well. The way we do that is through extensions, which I'm going to show you a little bit later on. There's a number of extensions that we have, starting from code analysis all the way to best practice, recommended practices on how you deploy infrastructure to clouds. Excuse me. We'll get into that. One of the things that's a key differentiator in the space now for us is obviously we've acquired GitHub. We are the second largest contributor to GitHub. Microsoft embraces open source. If you look at our cloud solutions today, any of our PaaS services in Azure right now that are starting to hockey stick in terms of popularity, they're open source solutions. Kubernetes, we've turned that into a PaaS service, Azure Kubernetes Services, because we see the value in the open source world, right? A lot of major companies are using these technologies and adopting them. Microsoft sees that, and we're also doubling down on this space as well. Okay? What's interesting about Azure DevOps is the costing associated with it. So for small teams, it's a free service. You know, in all intents and purposes, we're offering these tools, this integrated pipeline in a free way to allow you to adopt DevOps practices and principles, as well as building out software in quicker release cycles. Okay? Like I said, along the pipeline, you can use Microsoft technology, you can use your own technology, you can use open source. We really don't care. Well, the idea behind it is we're creating that seamless pipeline through the back end that gives you a consistent and repeatable process that's auditable, and you can report on it. Yeah, so this is just reinforcing the fact that, if you've got your initial investment on something like Jenkins build server, leverage it absolutely. Just call it from an Azure pipeline, and we'll let Jenkins do all the heavy lifting. Jenkins will provide the reporting back into Azure. Success, failure, reporting, audit logs, et cetera, et cetera. So, DevSecOps. So, the definition here is basically, DevSecOps is ensuring that we can use the modern practices and deliver value quickly, but still keep our services secure. Essentially, at the pace that we're innovating, we're releasing features at a bi-weekly cadence for, let's say, our Azure features. We just can't release those in a way that hasn't gone through the appropriate vetting and security checks, right? So what ends up changing here is not so much of a building out that software and then handing it over to a security team that would spend a week or 2 weeks on going through controls. The idea behind it is embed those controls as part of the DevOps pipeline and shifting left. So we've heard that term a little bit earlier in terms of shifting left. Just want to be clear on what that means. Shifting left, if we're given a spectrum, right, and we're setting this up, on the far left, we have source repository build, release. Moving further to the right, all the way to production, right? In a traditional model, we wait till things get into a suitable environment, QA, staging, pre-staging, or pre-prod, and then we perform our deep analysis from a security perspective, right? Instead of waiting for that stage, let's shift that process left, right into the DevOps pipeline for building, doing the static code checking, running unit tests against particular lines of code, enforcing policies to make sure that our developers are implementing proper algorithms. We can get down to the level of, without having any human interaction, we can ensure that they're calling appropriate APIs instead of using an MD hash. We're making sure that we're using like SHA-256. All these sorts of things need to be enforced and checked. But historically, it was a lot of manual process. Now we can take advantage of DevOps pipelines and extensions to do this. Microsoft's, this is the way we build our software. Every bit of software, every feature that's released now from Microsoft, every bit runs through Azure DevOps. Okay? So we're really their largest customer. So this is just a bit of a mindset shift. This is one point that I want to just make resonate with you is when we talk about the future and security, Microsoft is looking at it from a very specific lens. We're assuming breach, right? It's not so much about building bigger walls anymore, and I don't need to profess to you as security experts in the field, but a lot of customers I see in the MTC come in. Every day I have a new customer, and some of the larger fintechs tend to have the mindset of we're gonna leave everything on premise that's insecure. When in fact, I argue with them, and at the end of the day, they actually see the light at the end of the tunnel. In most regards, moving workloads into something like a public cloud that has the appropriate controls, security controls in place, you're in fact more secure than you would be in your own walls. One, from a perspective, we've done the homework, we've done the due diligence, we've hired the experts to enforce and make sure that all of our customers are secure, right? Two, taking advantage of additional services that are just not available in an on-premise environment. Things like AI that you just can't afford to implement in closed doors behind your four walls. Taking a look at things like behavioral analysis from an identity perspective. At Azure Cloud, we leverage an identity store called Azure AD, which basically is a replica of your on-premise Active Directory. Just by moving into the cloud and those workloads and taking advantage of that modern authentication technique, you're now getting the advantages of those cloud identity stores. Multi-factor authentication, it's just bolted on. B2B scenarios, B2C scenarios, behavioral analysis around identities, understanding that user A that logs in at 10 o'clock from a Toronto-based IP can't physically log in from a Vancouver-based IP at 10:45. Just physically impossible to travel that distance, right? So what do? We have these security controls already built into the platform today to initiate MFA responses and then trigger off a password reset in those types of scenarios. Okay. Now, back to DevSecOps for a second here. Some of the two, widest backdoors, credential theft, and then finding vulnerabilities. Okay? So credential theft. Phishing, one of the most popular ways of stealing someone's credentials. This is just an example of email that went out that people would get Nokia Lumia phones. Not that I don't think it would be very popular today, but maybe if it was an iPhone, but not a Nokia, that's for sure. You can use that as a paperweight today, so we'll move on. Identity protection, right? So taking advantage of things like multi-factor authentication to help mitigate things like link wrapping in emails. Now, when we talk about credentials stored in source code, what did they look like? Again, these are just some examples to show you. XML file could be Azure artifacts or templates or ARM templates, but you get the point, right? We can take advantage of tooling like CredScan or some of the more advanced techniques like SonarQube's offering that's built right into the pipeline of Azure. Okay, so here's a couple of examples. I'm just going to move through these fairly quickly because I got a minute left, and I end up rambling. That's usually what I do. Let's move through here. Open source. This is one point I want to get across as well. So if you go to GitHub today and you deploy your, or basically push up your repository, one of the key features of enterprise GitHub within that space is the ability to do vulnerability scanning. So there's a tooling called White Source that you can take advantage of out of band of a DevOps cycle. I can actually inject that into a DevOps pipeline within Azure as a result to check, are all of my dependencies up to date? Are there any vulnerabilities with the code base that I've specified? Now, in a typical kind of single page application, Angular-based application, you have like a packages.json that has all your dependencies in there. Things like White Source will automatically scan that, make sure that your dependencies are up to date. That just comes as part of the platform. Okay. Just going to move through a couple of these. Code analysis built in, static analysis using credential scanners, FXCOP, SonarQube built right into the pipeline of Azure. Things like Qualys SSL Labs, we also integrate with them as well, directly in there. That can make or break a build, right? So being able to do this through a pipeline is very powerful. White Source, again. This is one last point before we move over. Secure DevOps Kit, CI/CD extensions. So not just from a code base perspective, but from a platform. Now this is targeted directly at Azure, sorry, a little biased, but this takes the tooling, takes the recommended practices, policies that we've implemented in our cloud platform, and turn this into CI/CD extensions. So let's say I'm deploying an ARM template that's going to deploy a bunch of VNets and a bunch of VMs and maybe a SQL Azure PaaS service. I can have this as a follow-on step that will make sure I've done this in the most compliant and secure way. So make sure my storage accounts have encryption enabled by default, right? So all my data at rest is encrypted. Now, talking about Microsoft managed keys, bring your own key and hold your own key options, that's another day level conversation we could have. But the tooling just plugs right in. You can see here through these pipeline security tools and compliance, I'll leave that up to you to go through the deck to actually get the details for that. Okay, with that, I'll open the floor to questions. Thank you.